Hello, Math 10Cs. In today's lesson, we're getting very close to the end of the unit on factoring. We're up to lesson number 7 now, and we're actually going to break this lesson into two parts. I realized that the previous lesson was a little bit long and didn't have a whole lot of time to complete some of the work. So I just wanted to do just a little bit of this lesson today and assign a few problems, and then we'll finish the remainder of the lesson number 7 in the next class. So our emphasis is going to be on another type of trinomial, and it's going to be referred to as a perfect square trinomial. So let's go through a little exercise to identify what a perfect square trinomial looks like. Okay, so we have these two expressions, p plus q squared and p minus q squared. So I'm just going to grab a pen, and again, anytime you have the p plus q squared, that's telling you that you need to do repeated multiplication. So p plus q squared would be p plus q multiplied by p plus q. And if we use the FOIL method to expand this, first time first would be p squared. Outside times outside would be pq. Inside times inside would also be pq. And then last times last would be q squared. The two middle terms are like terms, so therefore we can combine this so it gives p squared plus 2pq plus q squared. And if we do it for this one, so again, the p minus q squared is p minus q. So repeated multiplication. And then this would be first times first is p squared. Outside times outside would be subtract p times q. Inside times inside would also be subtract p times q. And then last times last would be plus q squared. All right, so if we combine the two middle terms, because they're like terms, you would get p squared minus 2 times 2pq plus q squared. All right, so let's fill in the blanks here. It says, we can see from above that the first term in the trinomial is, well, let's look at the connection here. So the first term in the trinomial is the p. So how do I get that? You take the first term in the binomial and you square it. So the first term in the trinomial is the first term in the binomial squared. The last term in the trinomial, so that's the q squared, that would just be the square of the second term in each of these binomials, or the second term, or you want to call it the last term. So that'd be q squared, q to the power of 2 would give you q squared, the last term there. Now, the middle term in each of them is, what you're doing is you're taking the two terms and the two variables in the binomial, you're multiplying them together, but all of them have a 2 attached to it. So not only are you multiplying the first and the second terms in the binomial together, you're also multiplying by 2. So we're going to say is twice the product Oh, just give me a moment here. My computer for a moment has decided not to respond. Okay, any day now. There we go. Jeez. Guess the computer can't process the fact that I am writing with a drawing tablet. Okay, so twice the product of the first and last terms in the binomial. So that'd be p times q times 2. Okay, so it says here in a perfect square trinomial, so the example we're going to use here is x squared plus 10x plus 25. It says the first and last terms must be perfect squares. So this is how we're going to test to see if it is a perfect square trinomial. So the first and the last terms must be perfect squares. and the middle term must be twice the product of the square roots of the first and last terms. Okay, this is very wordy, but I'm also going to add something else to the end right here, and then we'll make more sense of it in a moment. And I'll say multiply by the sine of the b term. Okay, so I'm going to spell this out a bit. So I'm going to say, if you have a perfect square trinomial, for a moment I thought it was going to freeze up again. So if you have a perfect square trinomial, if your perfect square trinomial is in the form ax squared plus bx plus c, and I want to write down the two factors. So if we go back up here, the first number in the binomial is actually going to be the square root of the first term in the trinomial. So what I would write here is this would be the square root of a times x plus b, or sorry, plus the square root of c. So the second term in the binomial is going to be the square root of the last term. So the square root of the last term would be the square root of q squared, which would just be q. So square root of c. And then we're going to multiply by the same thing. So this would be square root of a x plus square root of c. And we can actually write that as repeated multiplications. This would be square root of ax plus the square root of c. And we're going to square that. And then I also have ax squared. So let's look at a different form of this here. So let's say that we have ax squared. And then let's say that we are subtracting bx and then adding c. So the big difference here is that I have this subtraction sign in front of the b term. So if we have a perfect square trinomial in that form, then this would be equal to, it's going to be the same thing, except we're just going to flip the signs around. So instead of writing down plus here, we're going to write down minus. So this would be the square root of ax minus the square root of c. And then the square root of ax minus the square root of c. And then we can write this as repeated multiplication as square root ax minus the square root of c, and we're going to square that. Okay, now the first example says determine whether or not these are perfect square trinomials. Okay, so basically if it's a perfect square trinomial, it needs to meet the following criteria. Okay, so we'll clarify this up here too. Okay, one, the first and last terms must be perfect squares. Okay, so we look at this here. The number in front of a squared would just be a 1. So what I want to do is I want to test to see if the number attached to the first term and the last term are perfect squares. Okay, so the square root of 1 is 1. The square root of 4 is going to be 2. Okay, so we meet that criteria, no problem. Now, the other thing we need to check is we need to check to see if, and I'll write this down mathematically, the value of b should be equal to either plus or minus 2 times the square root of a times the square root of c. And
you can run, but you can't hide.
This sign here, whether or not it's plus or minus, that's going to be determined whether based on the sign in front of b. Now, I realize all the theory I've written down here is like quite confusing. So let's just go through this and like let's perform these tests here. Okay, so if it's a perfect square trinomial, the first and the last terms are perfect squares. Okay, so the first term is 1 attached to the a squared. The last term is a 4. They are perfect squares because you can take the square root of them. Now, the other thing I want to check is I need to make sure this b criteria works. Okay, so b would be equal to, now this is the value of b. It's the positive 4 here. Now, I want to look at the sign in front of b in terms of whether I pick the plus or minus here. So I pick plus, and I want to take 2, and I want to multiply by the square root of a. So the square root of a would be square root 1. I want to multiply by the square root of c, which is the square root of 4. So this would be 2 multiplied by the square root of 1 is 1, the principal square root. The square root of 4 is going to be 2. Therefore, performing this test is the value of b 4, and it is, okay? I can see right here that it does match up correctly. So because I've met these two criteria, so the first and last terms are perfect squares, they are, and b is 2 times the square root of a times the square root of c, it is a perfect square trinomial. So we'll put a little check mark here. Okay, let's look at this one, x squared minus 9x minus 6. Okay, so let's see, can we take the square root of these? So this would be a 1. Can I take the square root of the first one? Yes, the square root of 1 is equal to 1. Can I take the square root of 6? No. Okay, so immediately that's a problem because if it's a perfect square trinomial, that constant term has to be a perfect square. So that is not a perfect square. So I don't even make it past criteria number 1. So it's a not a perfect square. So we'll put an x here. This is not a perfect square trinomial. Okay, how about this one? So we have 4x squared minus 3x plus 81. So first of all, let's see if it meets criteria 1. Is the first term a perfect square? Yeah, because you can take the square root of 4, which is 2. And is the last term a perfect square? Yes. Okay, you can take the square root of 81, which is going to be 9. Now, the other criteria it has to meet is this b criteria. Okay, so b would be equal to, once again, the program is just not responding, so I just have to wait for the rotating blue circle of doom to go away. There we go. Okay, so first of all, whether you pick plus or minus depends on what the sign is in front of b. So here the sign in front of b is a negative, so I'm going to write down negative, and then let's test this. So we'll go negative 2 times the square root of a, which is square root of 4, times the square root of c, which is the square root of 81. And then this would be equal to negative 2 multiplied by the square root of 4 is 2, the square root of 81 is 9. And then if I multiply those together, negative 2 times 2 would be 4, and then negative 4 times 9 would be negative 36. So what we're doing is we're trying to see if we perform this test, do we get the actual value of the middle term b when I plug the numbers in here? And in this situation, you do. Okay, you do get the negative 36. Therefore, yes, that is a perfect square trinomial. Okay, let's look at this one. So we'd have a 1 here. Let's see if we can pass the first test. So we take the square root of 1, which is 1. Now, when you take the square root of the last term, you technically actually need to account for the sign in front of it as well. So I'd have to take the square root of not only the negative, the 16, but also the negative. Now, it didn't matter for part C, B, or A because there was a plus sign in front of them. But immediately this is a problem because you can't take a negative square root. Okay, so this one's not a perfect square trinomial. Okay, so this one's an x. All right, let's go down to the next example. It says fill in the blanks so that each of the following is a perfect square trinomial. Okay, so for the first two ones, we need to figure out, we need to basically fill it in so we get bx. Okay, we have x squared, so we're missing the bx term. Now, same with this one right here. So if I want to figure out the value of b, we can actually calculate it using this equation up here. Because it's a perfect square trinomial, it has to meet this criteria. So let's go ahead and do it. Okay, so b would be equal to, okay, so the value of a would be 1, and the value of c is 100. So first of all, whether it's plus or minus, well, there's a plus sign in front of here, so we'll put down plus first. And then 2, multiply by the square root of a, which is square root of 1, multiply by the square root of the last term, which is 100. Okay, so this would be b would then be 2 times 1 times 10. So this would then be equal to 20. So what goes in the blank here? It would be 20x. Okay, so that meets my criteria for what the value of b is in a perfect square trinomial. Okay, this one, it's pretty much the exact same thing. The only difference is there's a negative sign here. So the difference is when you calculate b, you'd have to put a negative in front of here. So it'd be negative 2 times the square root of the a term, which is multiplied by the square root of 1, multiplied by the square root of the constant term, so that's 100. And then this would be b is equal to negative 2 times 1 times 10. And this would be equal to negative 20. Okay, so what goes up here? We already have the negative down, so just be negative 20x. Okay, how about this one? The numbers are a little bit bigger. Okay, so we want to calculate the value of b. So b is equal to, so first things first, the sign in front of the b is a positive, so we'll put a plus here. And then 2 multiply by the square root of the first term. Okay, so that'd be the square root of 25. Multiply by the square root of 36. So that would be b is equal to 2 multiply by the square root of 25 would be 5. The square root of 36 would be 6. And therefore, 2 times 5 is 10. 10 times 6 would be 60. So my value of b would be 60. You got to add the x in there as well. So this would be 60x. Okay, now this one's a bit trickier because in this one, it gives you the value of a, it gives you the value of b, but what I don't know is what's the value of c. Now, I can still use this equation for b to determine this, because if this is a perfect square trinomial, then b needs to be equal to plus or minus 2 square root a times square root c. So I'm going to use that equation, except this time around we're going to solve for what c is as opposed to b. So let's write that equation out. So this would be b is equal to, okay, first of all, the sign is a plus because that's a sign in front of the b term. So you'd have plus 2. Let's erase that. I went to the square root a bit too quick. Okay, 2. And then multiply by square root a, and then multiply by square root of c. Okay, let's plug the numbers in right now. So if I do that, b has a value of 24, and this would be equal to 2 times square root of a, which is 9, and then multiply by square root of c. We're going to calculate the square root of c in a moment. Okay, so this would be 24, would be equal to 2 times the square root of 9, which is 3, multiplied by square root c. So then I would have 24 would be equal to 6 multiplied by square root of c. And I want to get square root of c isolated. So to do that, I'm going to divide both sides of the equation by 6. Divide 6, divide 6. And then this would be, you'd have square root c is equal to 24 divided by 6 would be 4. Now, I don't want the value of square root of c. I want the value of c. So to undo a square root, you need to square both sides. So I'm going to take this and I'm going to square it. And I'm also going to square the 4 squared. So what that's going to turn this into is you would then have c is equal to 16. And that's the value up here. Okay, so I just had to solve it a bit differently. Okay, use the same equation except solve for a different variable. Okay, factor the following. Now, this is actually really easy to do if you just know if it's a perfect square trinomial or not. So if we test if it's a perfect square trinomial, then we can figure out the two factors pretty quick. So let's do our tests here. So our tests are the first and the last term perfect squares? Yes, they are, because the square root of 49 is 7, the square root of 1 is going to be 1. The second test is, let's do the b test. Okay, so b would be equal to, okay, there's a negative in front of the b, so negative 2, and then multiply by the square root of 49, multiply by the square root of 1. So this would be negative 2 times 7, multiplied by 1, and then that would tell me the value of b is negative 14. Okay, that's the same value of b that we have up here. So this is a perfect square trinomial. Okay, it meets the first test, which is the first and first and last terms are perfect squares, and it also meets the second criteria. Now, if it does that, we can actually use this equation to just simply write down what the factors would be. Okay, so what the factors would be is the first term, the first number is going to be the square root of a. Then we'll have like an x or whatever the variable is, plus the second term is going to be the square root of c. Okay, so if we go over here and do this, this would then be, okay, so the square root of 49 is 7. And then we're going to write down an x here. Now, this is a difference, so we're going to put this negative sign here. And then the second term is going to be just the square root of the last one. So the square root of 1 is just going to be 1. And then we write that down twice. So it'd be 7x minus 1, 7x minus 1. And if we want to write that as repeated multiplication, it'd be 7x minus 1 all squared. Okay, let's go to b here. Now, this one's not written in order of descending degrees. I'm going to first of all change it to that. So I'll write down 25x squared plus 40x plus 16. Okay, and let's quickly do our tests here. So my test would be, are the first and last terms perfect squares? Okay, square root of 25 is 5, yes. The square root of the last term is 4, so that works. Now let's also test to see if that b term is correct. So the b term would be, okay, so put a plus here because plus is in front of the b term, 2 times the square root of a, which is the square root of 25, multiplied by the square root of 16. So this would then give you b would be equal to 2 multiplied by 5 multiplied by the square root of 16, which is 4. And then 2 times 5 is 10, times 4 is 40, and that is the middle term. Okay, so we've met all the criteria for a perfect square trinomial. Therefore, to factor it now, it's pretty easy. So in the factor, the first number is the square root of the a term. So the square root of 25 is going to be 5. Then we write down the variable x. Here, the sign in front of the b term is a plus, so we'll put down plus here. And the square root of the last term is the square root of 16 is 4. So the second term is just going to be the square root of the c value. So we'd have 5x plus 4, 5x plus 4. And if we write this as repeated multiplication, this would be equal to 5x plus 4, and we are going to square that. Okay, last one. We got a fraction here to deal with. Okay, it's not a huge deal. Okay, so let's do our tests first of all. Okay, so the square root of 1 over 9, is that a perfect square? Well, if you have a fraction, like square root of 1 over 9, you can actually calculate this root by just separating the numerator and denominator into their own radicals. So this would be the square root of 1 divided by the square root of 9. That would be 1 over 3. Okay, so that is a perfect square. The last term, same thing. Okay, I can take the square root of 9, no problem. Okay, let's check the value of b. So the value of b is going to be equal to, so I see a negative sign in front of this, so I'm going to put a negative first. Then 2 multiplied by the square root of the a term, which is 1 over 9. And then multiply by the square root of the second term, which is 9. So this would be negative 2 multiplied by 1 over 3, because that's a square root of 1 over 9, multiplied by 3. Now, it turns out here that when you're combining these, just the 3 on the top here and the 3 on the bottom would cancel off. So you would then just be left with b is equal to negative 2. And because it matches up with this here, then you're all good, okay? So you can put a check mark here. Okay, and then finally, to now write down the factor, so we're going to write down the factor. Now, the first number is going to be the square root of the first term. So the square root of 1 over 9 is 1 over 3. And then we write down the variable, which is a. Now, the sign in front of the b is a negative, so you write down negative here. And then the square root of the last term is square root of 9, which would be 3. So we'd have 1/3 a minus 3, another 1/3 a minus 3, and then this would be equal to 1 over 3 a minus 3 all squared. Now, I should point out to you that if you do not like this, this method, because you might be wondering, like, well, how do I know if it's a perfect square trinomial or not? Or like, how do I know when to test if it's a perfect square trinomial? Well, the more of these problems you do, you can start to see a pattern and may be able to identify it a bit quicker. Usually a quick check or a dead giveaway is look at the square root of the first and the last numbers, and if they're perfect squares, then it's likely that the value of b is going to be equal to 2 times the square root of the first times the square root of the last. However, if you don't like this method and you still just want to factor it, you can use the decomposition method that we dealt with last time to do this, okay? It still works perfectly in terms of the steps for decomposition to factor these perfect square trinomials as well. It's just if you can identify it's a perfect square trinomial, it's a lot faster to do it as opposed to using decomposition. Okay, so we'll stop the lesson here, and you need to do, starting on page 368, and let's do a few questions here. So 368, numbers 1 through 3. And just do the do parts B, D, F, and H. So you can alternate the questions. All right, and then in the next lesson, we will finish up the second half of this lesson, number 7. We'll talk about some slightly more complicated trinomials. And I'll talk to you then.